Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to discuss another problem. Let me write the problem, then we will move to the solution. So the problem goes like this. The problem says penny being electrically neutral contains equal amounts of write it clearly, equal amounts of positive and negative charge. Question says, what is the magnitude of these equal charges? This is a problem. So before going to the solution, let me check the problem and try to understand first the problem. A penny, what's penny? It's a coin. It's a British monetary unit, and it is 1/100th of a pound. So it's a coin for us. So it says a penny being electrically neutral contains, it is electrically neutral. So it must contain equal amount of positive and negative charge. So as is stated by the problem, contains equal amounts of positive and negative charge. So what we are asked to find, what is the magnitude of these equal charges, meaning amounts of positive and negative charge contained in the penny. We have to estimate that. So let us move to the solution. Let Q be the charge. When I say charge, that is magnitude of positive and negative charges in the penny, right? So we are representing by Q the charge, magnitude of positive charge, and magnitude of negative charge in the penny, right? We can write Q equal to N Z E. What is N? N is the number of atoms in the penny. So N is number of, everything is composed of atoms. So penny is composed of atoms. When I say everything, that means matter, normal matter. So N is number of atoms in a penny. In a penny, right? And ZE is the magnitude of the positive and the negative charges carried by each atom. Carried by each atom, right? So if you know the magnitude of positive charge carried by one atom, you multiply that with the number of atoms, you get a total positive charge or total negative charge in the penny. So Z is the magnitude of the positive and the negative charges carried by each atom. Now let us move forward. I will change the color. The number n, first we have to find now the number of atoms. The number n of atoms in a penny assumed for simplicity to be made of copper is NaM or capital M, where I should write in which Na is the Avogadro's constant, M is small m is the mass of the coin, which is 3.11 grams, and the capital M is the molar mass of copper, which is 63.5 gram. Understand this point. I'm saying if we assume for simplicity that the penny is made up of copper atoms, the number of atoms in a penny can be written as Na times small m over capital M, where Na is Avogadro's constant, that is number of entities in a mole, here atoms in a mole. Small m is the mass of the coin, which is 3.11 grams, and capital M is the molar mass of copper, that means mass of 1 mole of copper or 1 mole of copper atoms, which is 63.5 grams, right? Therefore, I can write, think about it, it is easy. When you divide small m by capital M, mass of the coin with the molar mass of the copper, you get number of moles of copper in it, and each mole of copper contains any number of atoms. So it gives you the total number of atoms inside a penny. So I write N is equal to Na small m over capital M. I just put the numbers. You know, Avogadro's constant is 6.02 into 10 raised per 23. Here we are talking of atoms. So it is atoms per mole. Then you multiply with little m, which is 3.11 grams. Then you divide by capital M, which is 63.5 gram per mole. Check it, 6.02 into 10 raised by 23 atoms per mole multiplied by 3.11 gram divided by 63.5 gram per mole. If you see mole will go, gram will go, you will get just atoms, number of atoms. When you make the calculation, I will write it in red, you will get 2.95 into 10 raised power 22 atoms. Chuck it at home. Chuck it at home. You have to multiply these two numbers divided by 6.63.5, you will get 2.95 into 10 raised power 22 atoms. So we have calculated the number of atoms in the penny. Let us move forward. Then you know every neutral atom has a negative charge of magnitude Ze associated with its electrons, and a positive charge of the same magnitude associated with its nucleus. Remember, atom has a nucleus, then it has an extra nuclear part where there are electrons, right? You know that. I'm saying every neutral atom has a negative charge of magnitude Ze associated with its electrons and a positive charge of the same magnitude associated with its nucleus. What is E and what is Z? You know, here E is the magnitude of the charge on the electrons, on the electron, on one electron, on electrons, on the electron, which is, as you know, 1.60 into 10 raised power minus 19 coulomb. And Z, what is Z? Yes, Z is 29. It's atomic number of copper, or it's also called charge number, right? Number of electrons in the extranuclear part, you can say, or the number of protons inside the nucleus of copper atom is 29. Therefore, the magnitude of the total negative or positive charge in a penny is, then simply we have to multiply number of atoms with Z and E, is then Q is N Z E, and is, as we calculated it, 2.95 into 10 to the 22. Then you multiply it by Z, which is 29. Then you multiply it with the charge on the electron or proton, 1.60 into 10 to the power minus 19 coulomb. When you multiply these numbers, you get 1.37 into 10 raised power 5 coulomb. Let me encircle it with green. Multiplied n 2.95 into 10 by 22 with 29, which is Z. You multiply it by 1.60 into 10 raised by minus 19 coulomb. You get Q equal to 1.37 into 10 raised by 5 coulomb. This is our answer, but you check it, check the calculation, check it at home. This will engage you. If you see this charge, this is an enormous charge. It's huge. Right? By how can you get the estimate of the hugeness of this charge? It would take about, this will give you the estimate of the size of this charge. It would take about 38 hours for a charge of 1.37 into 10 raised to 5 coulomb to flow through the filament of a 100-watt 120-volt light bulb. Try to understand it. I'm saying this charge which we have obtained for a penny, inside a penny, magnitude of positive and negative charge is that much huge that it would take about 38 hours for this charge, which is 1.37 into 10 to the 5 coulomb, to flow through a filament of a 100-watt 120-volt light bulb. That means if I have a light bulb which is rated like this, which is operated at 120 volt and it gives 100-watt of power, then this much charge will flow through its filament in 38 hours. The conclusion is there is a lot of charge in ordinary matter. Conclusion is that there is a lot of electric charge in ordinary matter. We need to understand it. Before leaving, I will summarize. We had to find the magnitude of positive and negative charge inside a penny. So we said let it be Q, it will be N times ZE, where Z is the charge number of the atoms in the penny, E is magnitude of charge on electron or proton, N is number of atoms. Then we assumed for simplicity let it be made up of copper only. Then copper has atomic number of 29. Then we said number of atoms in the penny is Avogadro's constant times small m by capital M, where small m is mass of the coin and capital M is molar mass of copper. Then we calculated the number of atoms in the penny, and I told you to check this number. Then we said charge on electron or proton is this much coulombs, and the charge number is 29. We multiplied them and we got our answer. This is our answer. And then we compared its size. We gave a comparison of its size. We said it is a huge charge. And in the conclusion, we said there is a lot of charge in ordinary matter. This is all for today. Don't waste your time. Make a notebook of these problems. It will be helpful for you. And don't forget to like and subscribe my channel. You can comment in the comment box. Thank you. God bless you. Assalamu alaikum.